Hello, good morning. I'm going to do a very quick video over number 14 and 16 in our practice problem packet, just to hopefully shed some light on issues that might be confusing when it comes to confidence intervals. So number 14, I have a lot of it kind of already mapped out. We're going to go through it, and the part I really want to talk about is part C. So in number 14, suppose a researcher is interested in investigating the effectiveness of a new medication aimed to treat HIV. The following table represents the CD4 cell count for a simple random sample of individuals treated with the new medication. So here you have your patients A through R and the CD4 count associated with them with the treatment of the new medication. Okay. Part A asks us to calculate a 95% confidence interval for the average CD4 count of the population. This is where we have our x bar plus or minus our z of 1 minus alpha over 2. That's where we get our 1.96, and then multiply by the standard deviation over the square root of n. So you can see the values corresponding above. We're going to get a confidence interval of 294.4127 to 316.5873. That is our confidence interval at 95%. Part B, the way we interpret it, we say we are 95% confident that the true CD4 count lies between this interval, right? We don't know exactly what the true count number is, the true mu is, but we know it's between this interval, and we're 95% confident on that. So part C is assuming the researchers hypothesized this new medication would increase to at least 290 cells per cubic millimeter. Use your confidence interval to answer the question as to whether or not the researchers met their goal. So for this, we have to look, right, we hypothesize. So we're going to go kind of back to our hypothesis statement. Right? So if you're testing a new HIV drug, right, and you want to make sure that it would increase to at least 290, well, this is going to be our null hypothesis. Our H naught is going to be mu is going to be equal to 290 cells per cubic milliliter. Our alternative hypothesis, the one we're testing for, is we're going to say mu is going to be greater than 290, right? That's what we're trying to do. We're trying to increase it to over 290 cells per cubic milliliter. So if you look at that just at kind of like face value alone, right? We had an average of 305 when we averaged it out, from this population. This population got this. If we took another population and looked at their average, it'll be different. We look at another population, their average will be different. This one was 305, and this is where we get our confidence interval, right? We're saying that based off of this sample and multiple samples that are probably done, we would be 95% confident that the true value lies between this confidence interval. Well, our confidence interval is higher than 290, right? Even at the very lowest point. So say, the actual true average is 294.4, well, that's above 290, right? So we're already guessing correctly from alternative hypothesis. So we're going to reject the null hypothesis. For some people who need to see this a little bit more visually, let's think about it this way. If we have, let's say this is our normal distribution, this is our mu, which we want to say is 290, right? Well, our confidence interval is going to be right over here, right? And this is going to be 294 to 316. For space purposes, we'll say it's this, right? So you can see our confidence interval over here, it's not capturing our mu, so we're going to reject the null hypothesis, right? Our alternative hypothesis is one that is looking more accurate. So you're going to reject your null hypothesis, and you would say that the new medication is working, right? Our alternative hypothesis, we want to increase it above 290. So moving on to number 16, we have a new vitamin supplement program that is intended to decrease the average resting heart rate of individuals at risk for hypertension. Assume that a team of researchers are hopeful that resting heart rate in their population will get down to at least 68 beats per minute in a population with a standard deviation of 2 beats per minute. In order to test this goal reduction, the team gathers a simple random sample of 273 participants in the program and calculates a simple average resting heart rate of 74 beats per minute. So now we have a population that we're looking at, right? And the whole goal of this entire experiment is that you have a new vitamin supplement and you want to decrease their heart rate to less than 68 beats per minute, right? So let's go back to our writing a alternative null hypothesis. So our null hypothesis is going to state that mu is going to equal 68 beats per minute, right? And our alternative hypothesis, HA, is mu is going to be less than 68, right? We want to get down to at least 68 beats per minute, right? So that's what we want. We want people who are taking this new vitamin that their new resting heart rate is going to be less than 68 beats per minute. So they go out, collect participants, calculate their average resting heart rate, and right off the way, you can see that the resting heart rate after taking them is 74. It's not even close to 68, so you already know that they didn't meet their goal, right? So now we're going to use statistics and show, how far away from the goal they actually were. So here's your Z test or Z stat calculation. And you're going to have your 74 minus 68 all over 2 divided by the square root of 273, and that's going to be 6 over 0.1210, which equals 49.5867, right? So that's our Z stat right here is equal to 49. Right, and that's telling us that this is 49 standard deviations away from the mean, from the mean right now. And if you go in the back of the book, we know that anything above like 3.49 is going to give you a very high p-value, right? And so when we're looking at p-value here, though, let's kind of draw this out. Here's your mean or mu you're trying to get at, which is 68. And this is going to be 49 standard deviations away from the mean way out here, right? And 49 standard deviations, right? This is very, very far away from the mean. And then our alternative hypothesis, right, over here, we're looking at everything under 68 beats per minute, right? So if we're over here, right, this is where we are. We're over here, and we're looking for anything under 68. When you go to the back of the book, you know this is your p-value is actually going to be 0.9999, right? Because remember, the p-value tells you from that point and everything less than. And that's exactly what we're looking for. We're looking for anything at a point in less than. So we don't subtract it by 1, because the only reason we subtract it by 1 is because when we're looking for anything greater than a value at a particular point using the back of the book. So our p-value is 0.999, right? And alpha level 0.05. Well, our p-value is greater than alpha, so you're going to reject the null hypothesis. Once again, you can also show this when you interpret your confidence interval. Sorry, I don't know why Word does that. Thinks I'm not typing or something. When you construct your confidence interval, you have your 74 plus or minus 1.96 times the standard error, and you're going to get a confidence interval of 73.7628 to 74.2372, right? And as you can see, like even here, our confidence interval is going to be, 73 to 74, which is greater than 68, which implies that all our alternative hypothesis is not going to is not there. We don't have it, so we failed to reject the null hypothesis. We couldn't say that it was wrong, and so that's how we interpret and show the confidence interval. And this is where we would say that we are 95% confident that the true value of the resting heart rate for people who take this vitamin supplement lies within this interval. That's where we go, and this is kind of like the graphical showing of all of of this problem here. So this is where we get our p-value and alpha, and this is where it's really going to start being important to know about our null hypothesis and alternative hypothesis, and where it is exactly we state it's at, and what side of the graph we're looking for. Some of the other problems have been set up to be a little bit more accurate, so it's a little easier to tell, but now it's, going forward, these type of problems, the null alternative hypothesis are really going to come into play. Okay, so that's all I wanted to show you for those two problems. And once again, if you have any questions, please feel free to contact me or come visit me during office hours.